Yeah, welcome to class 5. Welcome to class 5 of JAMB Chemistry. Look at the question given to us. But remember, if you have not subscribed to this channel, therefore to subscribe. And when you are subscribing, hit your notification bell for what? Notification. Then share and comment after you have what? Subscribe on this what? Channel. Let's go to question. He said, this is the compound given. This compound is given. And they said, the compound contain a sp3 hybridized carbon atom only, b sp2 hybridized carbon atom only, c sp3 and sp2 hybridized carbon atom only, d sp3 and sp2 hybridized carbon atom. These are our solutions. Before we answering this, we have thought about sp3 hybridized in our what? Class 4. Then we also thought about what? sp2 in our class 4. Then let's go into what? sp in this class before we go into answering this question. Let's go to what? sp2 hybridized before we answer this question. I have mentioned sp3, then we'll learn to sp2. Now we are dealing with what? sp hybridization. In this sp hybridization is only formed by mixing 2xp. That is mixing this man 2x1 plus what? 1 electron from what? 2p. 1 electron from 2p mixed with this man is what we use to form what? Look at it, we call it xp. Means 1 from p orbital and 2 from p and 1 from what? xp, x what? Orbital. Look at, let me detail it for you now. When I said xp3, what does it mean? It means 1 electron from what? X orbital and what? 3 electron from what? P orbital. And where are they? This is 2x orbital. And this man now plus what? That's 1 electron plus what? 2p3. If you now add this and this, it will give me what? What we call xp3. That means 3 electron from what? 2p orbital and 1 electron from what? 2x orbital. Then for me to form what? For me to form xp2, this xp2 means 1 electron from this man, which means what? 1 electron from what? xp1 plus what? 2 electron from what? 2p orbital. 2 electron from 2p orbital form with what? 1 electron from what? 2xp, 2x orbital will give me what? What is it going to give me? It will give me what? xp2. And this is 1 here mixed with this 1 here, which is 2. This man is only 1. Anything raised to power 1 is that thing, and this raised to power 2. I think this one is raised to power 1, and anything raised to power 1 is that thing, and p raised to power 2. Look at it here. We say that this mix up with the 2 of this man is only 2. Why on this place he mix up with 3? Here he mix up with what? 2. Then now coming to, can I come over here? Coming to what? xp. What does it mean? It means that what? It mixed up with what? 1x orbital, that is a 2x orbital, I mean to say, plus what? 2p1. That's, it make use of only 1 electron here, make use of 1 electron from this man, which is 2x1 and 2p1. Add together to form what? What are they forming? xp hybridization. We form what? x what? P hybrid. That is a 8p what? Hybrid. That's what they form. That's 1 electron from p orbital and 1 electron from what? 2x orbital. And what? When did this thing occur? At excitation state of what? Carbon. When carbon get to what? Excitation state. That's when we'll be able to form sp3, sp2 and sp. Remember, but in a grand state of a carbon atom, he cannot form this. It's only formed in a what? Excitation what state. Then let us go to what? The hybrid. I said xp hybrid orbital is formed when one electron, now listen it, one electron from the 2s orbital, one electron from what? 2s orbital of a carbon atom mixed up with only one orbital of 2p orbital. Only one what? Electron of what? 2p orbital. Mixed up with what? Only one what? Electron or orbital of what? 2p orbital. Here, only one orbital of the p orbital is hybridized, thereby leaving two of the p orbitals, py and pz, unhybridized. What does it mean? You know that in p we have px, py and pz, which has one electron, one electron. What does it mean? Look at this. Look at this. Look at this here. What we have here is 6 and 1 spinning, and this is what? 2px and what? 2py and 2pz. And this man here, which will have what? Spinning, which is what? 2x1. This man used this to mix with this. They mix this and this to form what? To form what? xp hybridized. Leaving these people, look at this, these two unhybridized. Leaving these people unhybridized. Why this man is the only one that hybridized? This one unhybridized. And because he leave these two unhybridized, they are used to form 2 pi in the what? Bond. And where they occur is in the what? Triple bond. We say that this occur in the what? Can you see here? Triple what? Bond. So when I said here that what? Note, the two unhybridized p orbital are used to form what? Pi bonds. And what? There are two pi bond in this case. That's there are what? 2 pi bond. What I want to put here, there are what? 2 pi bond in this what? Case. Then when I said xp hybridization is found in what? Alkene. Alkyne, I need to say in a what? Alkyne. This is called what? Alkyne. Why this one is called what? Alkene. This is alkene. This one is what? Alkyne. Why this man is called what? Alkane. This alkane, and what? Alkyne. So xp is hybridization is found in the what? Alkyne. In what? Alkyne. Found in what? Alkyne. Then the shape of xp hybridized is linear shape. Look at the shape. The shape is linear shape. That's why it has what? 180 degree as the angle between the bond. We say the bond angle is what? 180. Then I now come to this. Looking at it now, it has how many bond? Triple bond. 1, 2, 3. Then single bond is what? Sigma bond. When I say this is the single bond that is supposed to exist, that is the sigma bond. Why this man and this man appear as a result of what? Unhybridized 2p. Then when I say they form 2 pi bond. So now look at sigma bond. So when I say sigma bond here has what? How many sigma bond do we have? 1, 2, 3 in a what? Alkyne. Sigma bond is 3 in alkyne. Why what? Pi bond is what? 2 in a what? Alkyne. We now come here to say the percentage x and p in what? Xp. You now see the percentage. I have already explained this becomes what? X over xp. And what is x? X is 1. What is p? X1. And p is what? 1. I have this 1 over 2 times what? 100, giving me some 50%. And this man now, percentage of p is 1 over what? Xp, which is total, times 100 over 1. And p is 1, and x is 1, and p is 1 as well. Then we now add it together. I have 1 over 2 times 100, and that gives me what? 50. We now see 50%. That's why we see what? Xp, they are equal in number. So that's the percentage of x and what? P in what? Xp hybridized. Yeah. Sigma bond and the pi bond. We said sigma bond and what? Pi bond. And what do we use to represent pi bond? Sigma bond and what? Pi bond, which we represent like this as pi bond. When I said single bonds or sigma bonds are those bonds that link x orbital or xp or pp orbital, and they are similar. They are single bond that join this man to this man, this man to this man, this man to this man is a single bond. That's what we call sigma bond. Example: this is a hydrogen chlorine molecule. This is chlorine molecule. This chlorine molecule is held together by what? Sigma bond. Look at it, single bond. Are you get what I'm saying now? Then coming here, this is a hydrogen molecule. This hydrogen molecule is held together. One element of hydrogen and other element of hydrogen hold together by a single what bond, which we call sigma bond, form what? Hydrogen molecule. Just the same thing as in the what? Chlorine molecule. Then you have what? The methane, which is the first bond of alkane. We have single bond, and which is what? Sigma. Then coming to this is the propane. Propane still have single bond. This is sigma bond that hold all the family of alkane series. Alkane series, all the family of alkane series is hold the bond there is what? Sigma bond. It's a single bond that hold what? Alkane series. And that's why we say that alkane is what? Saturated what? Hydrocarbon. Is a saturated hydrocarbon as a result that it has only what? Sigma bond, nothing like pi bond. Then coming to this, we say pi bonds are those extra bonds. The extra bond after the single bond, other extra bond is called pi bond. If you have after the single bond, if you can't have an extra bond, that extra bond is called what? Pi bond. We say pi bonds are those extra bonds other than single bond that link XX, XP or PP. Example, look at this. He link PP. How many bonds are linked? 2. Out of these 2, 1 is pi bond. The remaining 1 single bond is a what? The sigma bond. Coming to this, we have what? Alkyl. This is alkyl. This is alkyl. This alkyl series, we see that what? Triple bond are there. This triple bond, the extra 2 bond are pi bond. Look at it. Are pi bond. The single bond which is supposed to hold them is a what? Sigma bond. We now come to another example. You come to this, which you can see in what? Acanal. You see that what? Double bond holding hydrogen. Look at the double bond holding what? Oxygen with what? Carbon. How many bond now? 1, 2, 3, 4. And this extra bond is called what? Pi bond. Have you seen what I put it? Pi bond. Why this man is what? Sigma bond. Coming to this now, this carbon reacting with oxygen, this one reacting with oxygen as well. You see that double bond appear here. Then therefore what? The main extra bond there is pi bond. Extra bond here is pi bond. Have you seen the example of this? We now come to this note. When a sigma bond and a pi bond extra exists between 2 atoms, we call it what? Double covalent bond. Double covalent bond is this one. This man, we call it what? Double covalent bond, because sigma and pi bond exist in this particular compound. Only sigma and pi bond exist there. And it's single pi bond and single sigma bond. We call it what? Single what? Double what? Covalent bond. But in this place, how many is existing here? 3. Look at it. 3. 1, 2, 3. We call it what? Triple what? Covalent what? Bond. Look at it. We call it triple covalent bond. But when it has only 2 double bond, we call it what? Double covalent bond. When it has triple, we call it triple covalent bond. Yeah. The question says, look at the compound given. They said the compound contains, look at the compound. The compound contains A, xp3 hybridized carbon atoms only. B, xp2 hybridized carbon atom only. C, xp3 and xp2 hybridized carbon atoms. D, xp3 and xp2 hybridized carbon atom. We don't know. We come to solution. and solution. And what is this? These structures are called what? Toluene, which is a benzene structure, which we call toluene. When benzene react with what? Alkyl group. Look at alkyl group. Given to what? Benzene as a what? Branch chain. We have what? Toluene. And these are the carbon number 1. Look at the carbon number 1, number 2, and 3, and what? 4, and what? 5, and 6. This is carbon number 1 of what? Benzene. When the alkyl group are being an attachee or substituent of this benzene and carbon number 1, we'll call it what? Toluene. Then, what they ask us here is the what? Hybridization that exists in this benzene toluene. So when I see that in this we have double bond, benzene have double bond and a single bond, and this double bond is what we call delocalized. What do I mean by delocalized? This double bond can come over here, this one come here, and this one come here. Not that they are stagnant. They are not stagnant. This double bond can be stated here. This particular one will come over here, and this one will come over here. That means they are delocalizing. That's what we call delocalized. So these double bond are delocalized, and we have a single bond and double bond. And I said in our former class, which is class 4, this double bond has what we call what? Pi bond and a sigma bond. This made it what? Pi bond and a sigma bond. And for this pi bond to what occur, and what appear this pi bond, means that it has a what? sp2. sp2 is what produce one what? Pi bond as a result of what? One hybridized orbital of what? sp2. One unhybridized hybridized orbital of sp2 is used to form what? Pi bond. And these sp2 are found in the what? Ethyl, as I said. Then this is what? sp2 hybridization. That's what is found here. We find the what? sp2 hybridization on these two bonds, and this single bond we find what? sp3 hybridization are found in a single bond, but in the double bond we have what? sp2 hybrid in double bond. Why? This man has a what? 3 p orbital electron being what? Hybridized. Therefore, we form what? Single bond is what? sp3 hybridization are found in a single bond, which one of them is what? Methane, which is what? Alkane series. Why these double bond are found in the what? Alkene what? Series. And the triple bond are found in the what? Alkyl what? Group. So now, look at this. This man has double bond, which is sp2 exists in what? Double bond, while sp3 exists in what? Single bond. Then now, when I see that what? The same this man can also exist, what exists in what? Phenol, look at the structure of phenol, which has double bond and what? Single bond. And the phenol is as a result of what? OH, which is what? A function of what? Alcohol. This OH being attached to the what? Carbon number 1 of what? Benzene, we form what? Phenol. When this man is attached to carbon number 1 benzene, we form what? Phenol. Then the same thing in benzene, you see that benzene has double bond and what? Single bond. And also in this man, which we call nitrobenzyl, you see that what? Nitrogen oxide having what? Attachment in carbon number 1 will form what? Nitrobenzene. So on this and this and this, we see that what exists in them is what? sp3 and the what? sp2. And this sp3 is existing as a result of single bond exists, and sp2 existing there as a result of what? Double bond there. So we now see that what? Among all this, what exists there, the type of bond that exists there is what? sp3 hybridization and sp2 hybridization. So my answer here will now be what? That should be what? Yes, answer should be what? Option D, which is what? Xp3 and what? Xp2 hybridization carbon what? Atom. That's what exists in a what? This toluene. That's what exists in toluene, phenol, and what? Benzene, and the nitrobenzene, and so many of them. So we now say that my answer is option what? D for this particular question. Yeah. The second question says, the second question on this class said, which of the following is true concerning the properties of benzene and hexane? We said, which of the following is true concerning the properties of benzene and hexane? And what does it mean? They said, A, both undergoes substitution reaction. B, both undergo addition reaction. C, both are solids. D, both can decolorize bromine water. I don't know the answer, but you remember here benzene is aromatic family. Benzene is one of the what? Aromatic family member. Aromatic, which we call rings. Then hexane is alkane series, which we call what? Homologous series of alkane, which is what? The 16th bond of what? Alkane. So this is alkane, this is what? Benzene, which is aromatic, and this one is what? Aliphatic. This hexane is in under what? Aliphatic, which is what? Alkane. While this benzene is a what? Aromatic. When hexane is what? Aliphatic. Structure. This is what? Benzene, rings, circle. We now go to solution. We now say benzene is a hydrocarbon obtained from the distillation of coal tar. Look at it. Distillation of what? Coal what? Tar. When we distillate coal tar, we produce what? Benzene. We say benzene is a hydrocarbon obtained from what? Distillation of what? Coal tar. Then we come and we say it has a molecular formula of what? C6H3, which indicates that it is an what? Unsaturated compound. That benzene is unsaturated compound. Let's go into its what? Features. We said 1. Benzene is unsaturated what? Hydrocarbon. You have noted it now. It's unsaturated hydrocarbon, which we know that unsaturated hydrocarbon. Then number 2, we say benzene undergoes substitution reaction. Man, why will benzene go into substitution reaction? Why is a what? Unsaturated? Because every unsaturated hydrocarbon goes into addition reaction. But benzene will not come here to say benzene undergoes what? Substitution reaction instead of what? Addition what? Reaction. He undergoes what? Substitution reaction instead of what? Addition reaction. Which unsaturated hydrocarbon undergoes? Every unsaturated hydrocarbon undergoes what? Addition reaction. But benzene undergoes what? Substitution reaction. Why should it go into what? Substitution reaction. Why is a what? Unsaturated hydrocarbon. But let us see why he goes there. We said B, why he undergoes what? Substitution reaction. We said benzene do not undergo addition reaction. Why? Due to existence of what? Delocalization of what? Electron clouds in benzene molecule, which account for the resistance of the benzene molecule to what? Addition reaction. Have you seen the reason why, despite that benzene is what? Unsaturated, he goes into what? Substitution reaction. Because of what? Delocalized what? And what? Electron cloud. Delocalized electron cloud. Look at benzene. Look at the structure of benzene. If I draw this, look at my what? Benzene here. Just watch what I'm going to do. Look at my benzene and watch here. This man and this man what? And what? This man. You see that this is what we call delocalized. This particular man is not constant. These two bonds are not constant. He can what? Undergo, that's why we say that benzene undergoes what we call resonance. Look at it. I cannot have this structure to be like this anymore, and we'll see how delocalize what? Delocalize. This man can come over here, and this man come over here, and this man come over here. Have you seen that they have delocalized? Look at delocalize of what? Electron cloud. Look at where the electron cloud is before. Then look at now, he have delocalized, moving from here to here. This is how they move. So we said the benzene has these properties of what? Undergoing what? Substitution reaction due to what? Delocalized what? Electron cloud. Due to what? Delocalized what? Electron cloud. That's the reason why benzene undergoes what? Substitution what? Reaction instead of what? Addition reaction, as it is what? Unsaturated what? Hydrocarbon. But he goes into substitution reaction. But why? Because he has delocalized what? Electron. Delocalized electron, which I show you here. This man, this man, this man. They are not constant. They keep on delocalizing, moving in a different what? Dimension. Therefore, this give benzene these properties of what? Substitution what? Reaction instead of what? Addition reaction. 4. Benzene does not polymerize. We said benzene does not polymerize. 5. What do we mean by polymerization? We'll come to a question that will lead us to what? Explain in detail of what polymerization. I don't want to go into polymerization right now, but we will see in subsequent class where we deal in thoroughly over what is polymerization. We say benzene does not what? Polymerize. When I say 5, benzene is symmetrically and planar. Planar means what? Is a what? A plane. It has an angle of what? 180. That one means symmetrically and what? Planar. Then we say number 6, benzene has 3xp3 and xp2. That's it. He has a what? xp3 and what? xp2 hybridized, which we have seen in subsequent question we have answered. Then we have 7, we say benzene exhibits resonance. And I mentioned of me resonance. We say benzene exhibits what? Resonance. Look at here. That is, its structure can be described as a contribution of 2 or more structures which differ from one another only in the distribution of electrons. But look at it. Look at what we call benzene resonance. I told you that this is the localized electron. They are not one place. As this man, look at where he is. Look at this man. Look at this man. Then now they have what? Delocalized. This man have come down here. This go over here. This one. They continue like that. So that means benzene has a resonance. He form what? Resonance. That we say benzene is bit what? Resonance. That's what we call resonance. He's not stagnant. And this property of resonance give benzene the what? Ability to undergo what? Substitution reaction instead of what? Addition reaction. And these properties, what we call delocalization of what? Electron, makes benzene to have the properties of what? Resonance. These properties of delocalizing of this electron give the benzene properties of what? Resonance. To exhibit what? Resonance. Benzene exhibits resonance as what? As a result of what? Delocalizing what? Electron in benzene. I have made it clear now. Then number 8, we say benzene is a member of what? Aromatic compound. I said it earlier. Aromatic compound is a word rings. And the family of aromatic compound, the first bond of aromatic compound is benzene. That's the first bond. Then we are coming towards the one we are comparing, which is what? Hexane. We see that hexane is a what? Aliphatic what? Compound, which is what? The first, one of the aromatic compound is a what? Alkane, an alkene, and a what? Alkyne. They are all aromatic what? Compound, which is what? They are all what? Aliphatic compound, which is what? Straight chain. Aliphatic compound is what? Straight chain. Then we'll come to features of what? Aromatic compound, which benzene is one of them. We say features of what? Aromatic what? Compounds. We say number 1, they are cyclic. That means rings. They are rings. Look at it. They are rings. That means cyclic rings. Then compound. 2, the molecules are planar. The molecules are what? Planar. Number 3, they are unsaturated and undergo what? Substitution reaction due to presence of delocalized electron what? Cloud. Due to what? Presence of what? Delocalized what? Electron cloud above and what? Below. Above and what? Below the rings. Look at it. Above and below the ring. Delocalized what? Electron cloud. Number 4, we say they are what? Having what? 4n plus 2. Are you gonna see electron involving in the delocalization? What does it mean? They have what? 4n plus 2 electron delocalize what? Delocalize the electron involved in what? Delocalization. But what does it mean? Look at it. We say general molecular formula. General molecular formula for what? Aromatic compound is given as what? General molecular formula of what? Aromatic compound is given as N plus what? 2 and what? H what? 4 N plus what? 2. This is general molecular formula of what? Aromatic what? Compound. This is general molecular formula of what? Aromatic compound. The first bond of what? Aromatic compound is what? Benzene. Let's see. N equals to what? 1 is first bond. Putting 1 here, I will have 1 times 4. Are you following me? 1 times 4, which will give me 4 plus 2 will give me what? 6. Then 1 times 4 will give me 4 plus this will give me what? 6. This is the what? First bond of what? First bond of what? Aromatic compound. Look at the general molecular formula. Are you following me? Of the word aromatic compound. Then the second bond, which is what? 2. We now put 2 here, will give me what? 2 times 4 will give me 8, plus this will give me 10. That means C what? 10. And this one, keeping here, will give me what? 8, and this will give me what? 10 as well. This give me what? 10. That's the second bond of what? Aromatic what? Compound. And when we do this, we now see that features of what? Aromatic compound, we have seen it. Then we go back to our what? Question. Back to the question. We say, which of the following is true concerning the properties of benzene and hexane? We have seen from what we have learned about the properties of what? Benzene, that benzene undergoes what? Substitution reaction, despite that is a what? Unsaturated what? Hydrocarbon. And the hexane, which is what? Alkane series. Alkane homologous series. One of the members of what? Alkane homologous series. And the alkane homologous series are saturated hydrocarbon. And they undergoes what? Substitution reaction. We now see that both benzene and what? Hexane, which is members of what? Alkane series, undergoes substitution reaction. We now see that option A is our rightful what? Answer. We said option A, my answer is what? Option what? A is my rightful answer.